Okay, remember from your reading that we have a few properties that we should already know. Don't forget the formula for calculating a confidence interval, which is a statistic plus or minus the critical value times the standard deviation of the statistic. Okay, you also already know that if you have two random variables and you're finding the difference of them for the mean, you can also separate the two means. Okay, you also have your p-hats or your proportions where the mean of their difference is also equal to the mean of each individually subtracted, which will also then become p1 and p2. You also could find the standard deviation, which again leads you to another formula here that you have. Again, we can still find that formula though because you've used it before in previous sections of the textbook. Okay, so just a few things to remember with the sampling distribution of p hat sub 1 minus p hat sub 2. Remember that you choose an SRS of size n1 from population 1 with a proportion of successes, which is p sub 1, and then there's a separate, totally different independent SRS that has a sample size of n2 from population 2 with a proportion of successes we label as p sub 2. Okay, the shape is, we're going to say, is approximately normal if all four of these conditions are all at least 10. Okay, the center is the mean of the sampling distribution, which is of p1, p hat sub 1 minus p hat sub 2, which is p1 minus p2, or their proportions. And to find their spread, it's the standard deviation of that sampling distribution, as long as each sample is no more than 10% of its population. Okay. Just like we had conditions for constructing confidence intervals before, we also have them when we're doing difference in proportions. Remember, you have to have random. The data has to come from two independent random samples or from two groups in a randomized experiment, which we're going to do later. The 10% condition, when sampling without replacement, you have to make sure that both samples are less than or equal to 10% of their equivalent populations. And then large counts, you have to check all four of these conditions and make sure they're all at least 10. Okay, so again, you're still doing n times p and n times 1 minus p. You just have to do it for each sample with each said proportion. Okay, that will lead us into our two sample z interval for a difference between two proportions. When the conditions are met, we can find an approximate confidence interval percentage that we want to use, and here we have our formula for it. So remember that we have this p1 minus p2 is just your statistic. We're going back to using z as our critical value, and then this square root here is finding the standard deviation of our proportions. Okay, remember that this here is also considered your standard error when you're going to find, if you're asked to find that. So here is also your standard error. So it's just using, again, p times 1 minus p over the sample size, but we're adding it to the second set of information that we're also going to have. Okay, remember z star is the critical value for a normal, standard normal curve, with its area being between z star plus or minus for each one. Okay, so let's use a problem that would jump right into using what we just saw in the previous slides. So presidential approval. Many news organizations conduct polls asking adults in the United States if they approve of the job that the president is doing. So say we want to find out, how did President Obama's approval rating change from October 2012 to October 2013? So there were two polls conducted. Gallup did one of 1,500 randomly selected U.S. adults on October 2nd to the 4th in 2012, and they found 52% approved of his performance. In the next year, they did another poll with 1,500 again, randomly selected U.S. adults from October 5th through 7th, but that only showed 46% approved of Obama's job performance. So the first problem that we might have to do is to calculate the standard error of the sampling distribution of the difference in the sample proportions. We're going to do from 2013 to 2012, and then you also need to interpret this value. Okay, so first things you need to do is remember the standard error formula. Okay, so when we pull out our two proportions from our samples that we have, we're going to have here our two different ones where we have p hat of 2012 is 0.52 and p hat of 2013 is 0.46. So we go over and we put it into our standard error formula here where we have 0.46 times 1 minus 0.46 over 1500, and then we have its equivalent. We go through and solve, and you should get, oh, pen's not working, you should get it equivalent to 0.0182. Okay, so that's your standard error that you were asked to calculate. Okay, that's going to come into play later when we're going to end up doing some more calculations. Okay, so now we also need to interpret what that means. Okay, so remember, for interpreting it, when you're interpreting the standard error, you're taking many random samples of 1,500 U.S. adults in both October 2012 and October of 2013. The differences in the sample proportions who approve of President Obama will typically be 0.0182 from the true difference in population. Okay. If you are asked to use these results of these polls to construct and interpret a 90% confidence interval, remember it's saying to construct and interpret, so that means that when you see those words, you end up wanting to use the four-step process when you see construct and interpret. Okay, so in order to do the four-step process, if we go through and we want to find them out, we want to first state, we want to estimate P of 2013 minus P of 2012 at the 90% confidence interval, where we then have to identify what P12 and P13 are. So P is the 12 is the true proportion of all U.S. adults who approved of President Obama's job performance in October 2012, and P sub 13 is the true proportion of all U.S. adults who approved of President Obama's job performance in 2013 of October. Okay, your plan. If the conditions are met, we will use a 2-sample Z interval for the proportion of the parameter for 2013 minus the parameter of 2012. Random, up above it tells us the data comes from 2 independent random samples. Okay, we have to check the 10% condition for both of our years. Okay, so can we say that in both years that 1,500 is less than or equal to 10% of the total population, or is 15,000 less than or equal to the total population of all U.S. adults? Yes, I would say that both conditions then are met for the 10%. So now we need to do the large counts, and when you're doing large counts, you actually have to do it 4 times, taking each year's sample size, multiplying it by its parameter. Okay, so as you can see, doing out all the calculations for each of the 4 different large counts, you can see that all of them are over 10 for each of them, so that condition is met. So now, since all 3 conditions are met up above, we can go forward and go along with doing the do piece. Okay, so recall what your P hats were. Okay, so remember that the 2012 parameter is 0.52 and the 2013 parameter is 0.46. So we're going to use the statistic plus critical value times standard deviation formula, where here, remember this is the general formula that you will use. Okay, so our P sub 1 for our formula is actually 0.46 because we're doing 2013 minus 2012, plus or minus 1.645. Remember that's your Z's critical value, which you get from your tables because you're doing a 90% confidence interval. You then have to fill in for your P hats over here where you have 0.46 times 1 minus 0.46 over 1,500 plus the second parameter. Okay, remember this is your standard error that we calculated up above. Okay, so you go through, do your calculations out, so you end up getting here is negative 0.06 plus or minus 0.030. And then you have your interval when you add and subtract, so you end up getting from negative 0.090 to negative 0.030 for your interval. Okay, after you calculate out your interval, you can then do your conclusion part, where after you have your interval, remember we are 90% confident that the interval from negative 0.09 to negative 0.030 captures the true change in the proportion of U.S. adults who approve of President Obama's job performance from October 2012 to October 2013. Okay, so based on your interval, is there convincing evidence that Obama's job approval rating has changed? Because 0 is not included in the interval above, we have convincing evidence that President Obama's approval rating has changed from 2012 to 2013 in the months of October. Okay, you can also go and perform this Z interval on your calculator. If you go to stat over to tests, you want to find the one that says 2 prop Z interval. You notice it's not on this screen. If you hit the up arrow instead, you'll see it's on the second screen there where B is. So if you go to 2 prop Z interval and hit enter, you're going to want to put in your x sub 1 and your n sub 1, your x sub 2 and your n sub 2. You have to do out the calculations, or you have to get them from up above here where your large counts is, because you want to put in the actual number, not the percentage that was given in the problem. So when we wanted to find out what exactly was the percentage for in 2013, we would have had to use the 690 for that out of 1,500, and our second one was in 2012, which was 780 because it was 52% of 1,500. Okay, we're doing a 90% confidence interval, so now we calculate, and here you'll notice that they change them into the proportions here, but now we end up with our interval of negative 0.09 and negative 0.03. If you can remember to do them in your calculator, it's a lot easier, because many people make errors here in the square root area where you're finding the standard error or multiplying it times the wrong critical value. So it just gives you a lot of security with what you're doing instead of making any errors over here for it. Or you can go through and do the calculations and check your work using your calculator. Okay, so this video hopefully helps in finding the 2 proportion Z interval for you, and there'll be another one in order to do for significance tests.